Hello, so this is the second makeup lecture, and since we are going to have the second exam soon, I will discuss various problems from various sections which are similar to problems that may appear on the exam. So first section I would like to talk about is 8.4, which is about systems of two equations with two unknowns, and I'm going to do one problem from that section, and it's problem 15. If you remember, we did actually a couple of examples from this section, but I will just give a review of all the sections that we are going to have on the exam. So problem 15 goes like this. It's called food science. The following bar graph shows the milk fat percentages in 3 dairy products. I did not draw a bar graph as it is in the book, but I just wrote what you can see in the bar graph. And it says that whole milk, one of the 3 dairy products, contains 4% of fat. Milk for cream cheese contains 8% of fat, and cream contains 30% of fat. So that's what bar graph says. And the question is, how many pounds each of whole milk and cream should be mixed in order to form 200 pounds of milk for cream cheese? So, in other words, you have whole milk and you have cream, and now you want to mix them to get milk for cream cheese. In order to get milk for cream cheese, the mixture should have 8% of fat. Now, if you take more whole milk than cream, the mixture might have percentage of milk fat closer to 4. But if you take much more of cream than of whole milk, the percentage in the mixture will, the percentage of fat will be closer to 30. So there must be somewhere in between the right balance of whole milk and cream in order for you to get a mixture that contains exactly 8% of milk, 8% of fat. Okay, so and you want 200 pounds of milk for cream cheese. Want 200 pounds of milk for cream cheese, so that means 8% fat milk. Okay, so let X and Y be the unknown quantities or the unknown pounds of whole milk and cream that you want to use in the mixture. So let X be amount of whole milk in the mixture, so in pounds. So whole milk in the mixture. So that's in pounds. And let Y be cream in the mixture, given in pounds. So the question is, what is X and what is Y? So the first requirement that we have is that the mixture of X pounds of whole milk and Y pounds of cream is supposed to give us 200 pounds of mixture of the milk. So if you have X pounds of whole milk and if you have Y pounds of cream, when you add them up, you are supposed to have 200 pounds of the mixture. So that's the first requirement. The second requirement, so this is about quantity. How much milk do you want to have? Now the second requirement is information about the percentage of milk fat that you want to have in the mixture. So you want to have 8%, and you deal with one component that has 4% of fat and the other component that has 30% of fat. So if you want 8% of fat, that means in total the quantity of fat that you want in these 200 pounds is going to be 200 times 8%. That is going to be the amount of pounds in the mixture that goes on the fat itself, pure fat. So pure fat in these 200 pounds of milk is going to be 200 times 8%, so that's 0.08. All right. So we want to have in total this amount of fat in the mixture. Now, part of this amount of fat comes from fat. Hello, just a second. That's okay. All right. So a part of this fat comes from whole milk. Okay. So how much fat comes from whole milk? Well, if we want X pounds of whole milk in the mixture, and whole milk contains 4% of fat, that means the total amount of fat that comes from whole milk is actually X times 4%. So it's X times 0.04. All right? And the amount of fat that comes from cream, if you have Y pounds of cream, the amount of fat that comes from cream is Y times 30%. Okay? So it's plus Y times 0.3 or 0.30. That's 0.3. Okay? So these are two equations that you have, and you want to find X and Y. So obviously these are linear equations. So you have a system of two linear equations with two unknowns. We know how to solve them. So one way is by substitution. So you can express Y using first equation. You can express Y in terms of X. So we get Y is 200 minus X. All right? Now use that information. So Y is 200 minus X. Put it over here for this Y. And what you will get is just equation in which only X appears. So you should be able to find X. So here is the strategy. So just write Y, 200 minus X instead of Y here. So X times 0.04 plus, and now we are substituting 200 minus X instead of Y times 0.3. And that is supposed to be 200 times 0.08. Now 2. So when you multiply by 200, this number, it's the same thing as if you multiply 2 by 2, if you multiply the number which is actually 2 decimal places, you move decimal point 2 places to the right. So this is just like 2 times 8, so that's actually 16. You actually should not use calculator for this simple calculation, although you can. All right? So next thing is to find X in this equation in which only X appears. To do that, the first step is to distribute, in other words, to multiply 0.3 with these parentheses. So you will have, let me write this as 0.04x plus, and then I have 200 times 0.3. Well, it's like 0.3 times 2 and then times 100. So it's like 0.6 times 100. So that's actually going to be 60. And we have minus 0.3x. That should be 16. Now the next step is to leave unknowns, that is x's, on the left and move constant 60 to the right. So if you want, I can, before moving constant 60 to the right, I can first add these up, or actually subtract. So I have 0.04x minus 0.3x. Well, that is going to be minus 0.26x, right? Because when you add 0.04 to 0.26, you actually get 0.3, which is actually 0.3. So that's what we have, and plus 60, that's equal to 16. Now move 60 to the right, in other words, subtract 60, and you get minus 0.26x equals 16 minus 60. 16 minus 60. And that's equal to, this is actually equal to 44, right? Minus 0.26 equals minus, I said 44, but it's actually minus 44, right? Because 16 plus 44 is 60. Okay, and times x. Let me see here, x. So to find x, you just need to divide by negative 0.26. So x is negative 44 divided by negative 0.26. And I think I have solution here. That is supposed to be approximately, so x is approximately 169.23. Okay, and that's the so that's 169.23 pounds of whole milk that we need in the mixture. Now we're not done. It remains to find the amount of cream that we need to put in the mixture. But that's easy, because if the total should be 200, and we know that we need 169.23 pounds of whole milk, then cream is just, the amount of cream that we need is just 200 minus 169.23. That's actually what we have here. So let me write that down here. So y is 200 minus x, which is 200 minus 169.23. So y is, again, this is approximately because x is approximate value. And that is going to be what? That is going to be 30.77 pounds again. So this is in pounds, and this is also in pounds. We had everything in pounds. The weight. Okay? So we need 169.23 pounds of whole milk and 30.77 pounds of cream. And when we mix them, we will get milk for cream cheese. In other words, we will get 200 pounds of milk with 8% of fat. Okay? So that's 8.4, problem 15. Okay, now let me do from section 8.5, let me do problem 12. All right, number 12 from 8.5. the system of three equations with three unknowns. So here is the system. 2x plus y plus 2z equals 11, and 3x plus 2y plus 2z equals 8. And the third equation, x plus 4y plus 3z equals 0. Okay, so we are looking for triples x, y, z for which this is true. Okay? I mean, for which all the three equations are true. Okay, so as you remember, the strategy is to reduce your problem to solving system of two equations with two unknowns. To do that, you need to get rid of one of these three. Okay, and to do that, you need to pick two pairs out of three possible pairs among these three equations. So two pairs of equations. In each pair of equation, you eliminate the same variable, and you will end up with two equations in which the remaining two variables survive. So you will get the system of two equations with two unknowns. Okay, so for example, let's take first and second. So that is going to be our first pair of equations. So first and second equation. The first equation is 2x plus y plus 2z equals 11, and 3x, that's the second equation, 3x plus 2y plus 2z equals 8. Okay? Now, which variable are you going to eliminate? Well, it might look like just multiply the first by -1, and then when you add these up, z will disappear. But then you will have to make z disappear in your second pair of equations. But the second pair of equations, obviously one of the equations must be the third one. But then you will have 3z and 2z. So you will deal with some, so you will need with multiplications with 2 and 3. One equation you will have to multiply by 2, the other one by -3 or something like that. So it might be better actually to eliminate y, okay? Because you will easily eliminate y here, and you will again easily eliminate y if you choose third equation and one of the two remaining as to be the second pair of equations. So let us multiply by the first equation by -2. And when you multiply the first equation by -2, you get -4x, -2y, minus 4z equals -22. That's the first equation after multiplying by -2. The second equation, I'm just going to copy. 3x plus 2y plus 2z equals 8. And now what? Now add them up, and y will disappear. That's why we multiply by -2. So we have -x, y disappears, and -2z equals -14. So that's our first equation. Or if you think there are too many minuses, you can multiply by -1. It's not necessary, but why not? X plus 2z equals 14, all right? So x and z are related in this way. Now there is another relation of x and y that you need, and to get another relation between x and between x and z, there is another relation between x and z that you need, and to get that one, take some other pair of two equations. So here we used first and second equation. Now we can, for example, choose first and third, or we can also choose second and third. But anyways, since we didn't use the third one has to be there, one of the equations, and the other one, it doesn't matter. So let's take first and third. The reason why we are actually taking first rather than second is because we have just y here, so it's easy to eliminate y. And since we eliminated y from this first pair, we definitely have to eliminate y again. Okay, so the second equation, the second pair can be 2x, so the first and the third equation. So 2x plus y plus 2z equals 11. And the other one is x plus 4y plus 3z equals 0. Okay? And again, eliminate the same variable that the same unknown that you eliminated in the first pair. So in our case, that's y. That is y. Now, so we multiply by -4, the first equation, in order to eliminate y. And so the first equation becomes now -8x minus 4y minus 8z equals -44. The second equation remains the same, and I'm just going to copy it. If you remember, there is a lot of copying in problems like this, solving systems of three equations. So now add these up, and you will have -7x, y's kill each other, and -8z plus 3z, that's -5z, that is supposed to be equal to -44. And again, it looks like a lot of minuses, so maybe we're more comfortable if we have pluses, so you can multiply by -1, but it's not necessary. Okay, but let us multiply. So we have 7x plus 5z equals 44. And here is our second equation. So both of them only have x and z. There is no y. So that's the important thing to remember. When you are taking two pairs out of these three equations, from each pair you need to get another equation in which one of the variables, one of the unknowns does not appear, but it has to be the same. It doesn't matter which one. In this case we chose y. We could have chosen x or z, but the point is, once you choose here to make y disappear, you have to choose y to disappear over there. Actually, there is no choice anymore. Okay, so let me put it here, the problem that we have now. For what values of x and z is this and this satisfied at the same time? So we have x plus 2z should be 14, and 7x plus 5z should be 44. Okay? Now x here has a coefficient multiplying it being equal to 1. So actually, maybe the easiest way would be just to multiply the first equation by -7. So in that way you will annihilate x, and only z will, you will get the equation in which only z appears. Alternatively, if you want to annihilate z, so if you want to make z disappear, you can multiply first equation by, say, -5, and the second equation by 2. Or first equation by 5 and second equation by -2. Okay, and then add them up. So, but I guess it's easier just to multiply one of the equations. So negative 7 multiplies the first equation, and we get negative 7x minus 14z equals, and this is minus 7 times 14, so it's 70 plus 28, so it's 98, negative 98. And we have 7x plus 5z equals 40. Now add them up. Of course, x will disappear, and you have minus 14z plus 5z, that's negative 9z, and that's equal to, and this is negative 58. I think the answer should be integers. So let me see where I made a mistake. Just a second. Okay, the mistake is when I was copying this equation here. I guess you guys already caught that when I was just copying this equation here, I wrote 40, but it should be actually 44. Okay, so then we have 44 here, and so when you add these up, you get what? You get negative 54. Okay? And now I said something's wrong because I knew in advance that z was an integer. It's supposed to be an integer. In general, z can be any real number, but so x and y as well. But most of the problems that you have in section 8.5, actually maybe all problems in 8. Well, not exactly all. Number 24 and number 20 and some other problems don't have integer valued solutions, but in this case, in most of the problems, all x, y, and z are integers. Okay, it's just because it's easier for you to work with problems where x and y and z are integers. So that's why most of the problems are such. Okay, so the mistake was here, and so we have now that z is negative 54 divided by negative 9. That's 6. Okay, so here is z. But we are not done. We still have to find x and y. So you can go back to, let's say, this equation, and we have x plus 2z equals 14. That's how you can find your x. So we have x plus 2 times z, and z is 6, equals 14. All right? So x plus 12 equals 14. So that means x is 2. Okay? And finally, we need to find y. So go back to any equation in which y appears. Let's say the first equation. Okay? So we have, let me write here, 2 times x. So that means 2 times 2. And then plus y, so plus y, plus 2z, so plus 2 times 6 equals 11. Now this is 4, and this is 12. 4 plus 12 is 16, so y plus 16 equals 11, which means y should be negative 5. Okay, so x, y, z, let me write final answer here. X, y, z is a triple where x is 2, y is negative 5, and z is 6. You must make sure that these numbers are in order, so that the first one is x, the second one is y, the third one is z. So that's the order that you need to put here. It's called ordered triple of numbers. Okay, so we are done actually, but it's always good to check since it's a lot of work, and I anyways made a mistake, although I rectified that, but you never know, you may make a mistake and it's hard to catch that. So the easiest way to check whether your solution is correct is just by going back to the original system of equations and plug in these numbers for x, y, and z, and all the three equations have to be satisfied in order for you to make sure that the answer is correct. So if x is 2, y is -5, and z is 6. Let's see first equation. 2 times 2, that's 4, minus 5, that's -1, plus 2 times 6 is 12, so it's 12, and -1, that's 11, so the first equation really is true. Now when the second equation, x is 2, so 3 times 2 is 6, and minus 10, 6 minus 10, that's -4, and you have plus 12, so 12 minus 4, that's 8. Well, that's what you have on the right side, that's correct. And the third equation, 2, and this is minus 20, so minus 20 and 2, that's -18, and you have these 6, so 3 times 6, that's 18. So you have -18 and 18, so that adds up to 0. So everything is correct. Okay, great. So this is an example from section 8.5. Now I will move to chapter 9. Okay, so chapter 9, section 9.1, problem 38. So solve this inequality. Okay, so we are looking for y, unknown number y, for which 5y plus 13 should be greater than 28. So the first thing is to get rid of this constant on the left, so subtract 13 from both sides, and you get 5y is greater than 28 minus 13. In other words, 5y is greater than 15. The next step is to get rid of coefficient 5 multiplying y. To do that, you divide by 5. So, if you remember, this is my notation for announcing that in next step I'm going to divide by 5, both sides of the equation. Now, since you are divided by 5, since you are dividing by positive number, you don't change the sign. Remember, we said that if you are dividing or multiplying inequality by negative number, then you need to change the sign or the direction of inequality. Okay, so in this case you don't do that, so you have y is greater than 15 over 5, that's 3. So this is the solution, and if you want to write solution set, so it's actually set of all y's for which y is greater than 3. In the interval notation it looks like this. Okay, sorry, from 3 to infinity, not including 3. Okay. Okay. Next problem. Problem 40. Problem number 40. Negative 9. So like 40. Negative 9x plus 3x greater or equal to negative 24. Plus 3x greater or equal to negative 24. Okay. So this is easy because the first step is actually to add these up. So these add up to negative 6x. That should be greater or equal to negative 24. And now you need to get rid of negative 6. So now you are dividing by negative 6. And since you are dividing by negative number, you need to switch the sign of inequality. So you will have x less than or equal to negative 24 over negative 6. So in other words, x is less than or equal to 4. Okay? Or the solution set, well, Yeah. The solution set S is set of all numbers less than or equal to 4. In the interval notation, it's this. So we use brackets to denote that we do include number 4. Okay? Next problem, 42. Okay, problem 42 says 8x minus 9, 8x minus 9 should be less than 3x minus 11. So we are looking for number x which satisfies this. Actually, it will turn out there are a lot of such numbers x. So let's find all of them. So to solve inequality means to find the solution set. In other words, to find all x's for which this is true. Okay? So the first step is to move knowns to one side, unknowns to the other side. So we can move 3x to the left, or in other words, subtract 3x. So we get 8x minus 3x and minus 9 is less than negative 11. Now this is 5x minus 9 less than negative 11. You also want to get rid of this known quantity, negative 9, to get rid of it on the left side. So you will add 9 to move negative 9 to the right. So you get 5x is less than negative 11 plus 9, which is negative 2. Okay? And now to find x, just divide by 5. Since 5 is positive number, we don't switch the sign of inequality, and we get x is less than negative 2/5. Whether you put minus in front of 2 and you have minus 2/5, or you put minus in front of 5, so you have 2 over minus 5, or you put minus in front of the whole fraction, it really doesn't matter. Minus can be in either on the 3 positions, and I tend always to write minus in front of the fraction, so negative 2/5. Okay, so solution set in interval notation is interval from minus infinity to negative 2/5. Okay? Usually I will ask you to write the solution in interval notation. Alright? So if you get up to here but don't write this, you will lose a couple of points. So don't forget if I ask you. If I don't ask you, then it's also fine to write just like this. Okay, next problem 45. Problem 45 goes like this. Uh, 5x minus 1/12, 5x minus 1 over 12, less than or equal to 5 over 12 plus 4x. Okay, for what numbers x is this true? Okay, so again, move all unknown terms to the left, or unknown variable to the left, and known constants to the right. So you want 4x to the left, so you subtract 4x and you will get 5x minus 4x and minus 1/12 less than or equal to 5/12. So this is just x minus 1/12 less than or equal to 5 over 12. Now you add 1 over 12 in order to get rid of negative 1 over 12 on the left. So you get x is less than or equal to 5 over 12 plus 1 over 12. So x should be less than or equal to, and 5 twelfths plus 1 twelfth is in total 6 twelfths. Well, that's 1/2, so x should be less than or equal to 1/2. Or to write a solution set in the interval notation, this is interval from -infinity to 1/2, and since we have also equal, so x can be equal to 1/2, so we include 1/2, and that's why we write these square brackets. Okay? You never write square brackets next to infinity or negative infinity, because those are not numbers. This just means, this is just another notation to say all numbers less than or equal to 1/2. It doesn't mean in between negative infinity and 1/2, because negative infinity is not a number. Okay? So we don't include that. Okay, next problem, 52. 52, where is 52? Here it is. Okay, a little bit more complicated. Let me erase this. 52 says, (8x) in square brackets, 8x minus 3 multiplying 3x plus 2, okay, close the brackets, minus 5 should be greater than or equal to, I guess I will have to erase this, should be greater than or equal to 3 multiplying x plus 4 and minus 2x. Okay. So what's the first step? Well, first of all, observe that there is really no need for these square brackets. You can just subtract this minus this, and after that you can subtract 5. So there is really no need for these square brackets, but maybe they are just there, the authors wrote it there to help you to let you know what should be your first step to do. And the first step is actually to distribute this 3 and minus 3 and then add these 2. Okay, so or simplify this. So maybe that's why they put square bracket, but it's really not necessary. So let me not write square brackets in the next step. And I have just 8x, and now I'm going to distribute negative 3. So I have negative 3 times 3x plus negative 3 times 2. Negative 3 times 3x is negative 9x, and I have minus 6. Alright? And then minus 5 greater than or equal to, let me distribute this. This is 3x plus 12 minus 2x. Now let's simplify, add whatever you can. Negative x from here, and minus 6 minus 5, that's negative 11. That is supposed to be greater than or equal to 3x minus 2x is x, and plus 12. Okay? Now it looks much simpler. Now move x to the left. So you will have minus x minus 11 greater than or equal to 12. Move minus 11 to the right, or in other words, add 11, and so you will get, this is anyways minus 2x is greater than or equal to, when you move this to the right, you have 12 plus 11. So minus 2x should be greater than or equal to 23. And you want to find x, so divide by negative 2, divide by negative 2, and so you have x on the left. Now, since since you are dividing by negative number, you need to switch the sign of inequality. So this becomes x less than or equal to 23 halves. 23 over negative 2. Or in other words, x is less than or equal to negative 23 halves. Okay? And the solution set in interval notation, so it's set of all x's for which x is less than or equal to 23 halves. So that set is interval from minus infinity to negative 23 halves, and we include 23 halves because x can be equal to negative 23 halves. Okay, so that's problem 52. Now let's do problem 62. The last problem that I will do from this section. Problem 62 is 2/3 multiplying 4x minus 3 greater than 30. Okay? So now it might look a bit trickier. So you can say, well, I should distribute 2/3. Well, that's one way, but you can actually also get rid of 2/3 by multiplying the equation by the reciprocal of 2/3, or in other words, to divide by 2/3. So to divide by 2/3 means to multiply by the reciprocal of 2/3, which means 3 halves. So let us multiply by 3 halves. So this will just become 4x minus 3, and on the left side we have 30 times 3 halves. So it's the same thing as 30 halves times 3. So that's 15 times 3. In other words, 45. If you are not comfortable, you can just multiply 30 times 3, that's 90. 90 divided by 2, that's 45. Okay, so I have this. Now next step is to move minus 3 to the right, or in other words, add 3, and I get 4x greater than 45 plus 3. By the way, you don't need to write step by step. You can immediately write 4x greater than 48, as long as you feel comfortable to skip some steps, okay? I usually skip some of the steps when I do some calculation by myself. I'm writing in so many steps just so you can follow. But in general, if you feel comfortable skipping some steps, you can do that. But be careful. Don't skip too many because you may make a mistake. And of course, if you skip so many steps so that it looks like you immediately got the solution and I don't see how you got the solution, you won't get credit for that. Problems, correct answers with no work or with just a little bit of work, which I wouldn't understand if I wrote just so few steps. That will not get you much of a credit, or will not get any credit at all. So you have to make sure to write some steps, and if you can follow your work, I can follow as well. But if you just immediately write what final answer is, that will not give you any credit. Okay, so now in this remaining step, we just need to divide by 4, and so x should be greater than 48 over 4. Well, that's 12. Okay, so this is the solution. Set of all numbers x which are greater than 12, and in interval notation, that's this interval. We don't include 12, so it's just a regular parenthesis. Okay, So that's chapter 9. Now let's deal with problems from section 9.2. So this was section 9.1. Now let's see 9.2. Okay, section 9.2. We'll first do problem 59. The title is Pressure at the Sea Depth. Okay, so here is water level. Here is a sea. Okay, and here is a diver swimming. Okay, and he has paddle and okay, mask, and here are some bubbles. Okay, and he is at level D feet from the water level, or the level of the surface of the water. And it says the equation P equals 1 plus D over 33 gives the pressure P in atmospheres. So the units are atmospheres, denoted by ATM. At the depth of D feet in the sea. Okay. So if you are 33 feet below the level of the water surface, you are exposed to the pressure of, if you plug in 33 here, this is just 1. So it's going to be 2 atmosphere. Okay. All right. Now the question is, for what depth D is the pressure at least 1 atmosphere and at most 7 atmospheres? Okay. So you want pressure to be at least 1 atmosphere. So that actually means that P should be greater than or equal to 1. So P should be at least 1. So P should be 1 or larger, and at most 7 atmospheres. So P should be at most 7. That means 7 or below. Okay. So the question is, for what values of D should P be in between 1 and 7? All right. So we have a formula, P expressed in terms of D, and we should find D. Okay. So that is 1 plus D over 33. That's our P. Should be greater than or equal to 1 and less than or equal to 7. Now, when you have 2 inequalities like this, this means that this quantity in the middle should be greater than or equal to 1, and the quantity in the middle should be less than or equal to 7. Okay? So, and is the key word. All right? So to find solutions of both inequalities, we can do at the same time or separate. But since the steps are the same, at least most of the steps, in most of the situations, then you can immediately do both at the same time. So what's the first step to find for what D is this true? Well, you want to get rid of this 1, okay? In this inequality, you would like to get rid of this 1. And in this inequality, you would like to get rid of number 1. So subtract 1, and you will have 1 minus 1 less than or equal to d over 33 less than or equal to 7 minus 1. Okay? So I just subtracted 1 from each side, and this became d over 33 only. Okay, so I have 0 less than or equal to d over 33 less than or equal to 6. Now I want to get rid of this denominator 33. To do that, I multiply by 33. So I have 0 times 33 less than or equal to d less than or equal to 6 times 33. So d should be greater than or equal to, or this is not 0.33, this is 0 times 33. Well, that's just 0, of course. And 6 times 33, well, 6 times 3 is 18, so it's 18 plus 180, so that's 198, okay? So D, if you want P to be in between 1 and 7, you want D to be in between 0 and 198 feet, okay? So actually D greater than or equal to 0, so that's where atmosphere pressure P is 1 atmosphere. Actually, that's why it's called 1 atmosphere. The pressure that you feel at water level is in fact, or sea level, at the sea level is where D is 0, and of course it's called atmosphere because that's exactly what you feel, just the pressure that comes from the atmosphere. All right. Now, when you go down below the sea level, you will feel the pressure that comes from atmosphere due to air in the atmosphere, plus some water which is above you. Okay. That's all, of course, due to gravity. So, if you wonder, if you know that your equipment is good only for the pressure of 7 atmospheres. If you want to see what does that mean, how much you can go down below the sea level, well, that means you want to see for what values of P, for what values of D is P less than or equal to 7. Okay, and so we know for 198 feet. So you can go with that equipment, you can go up to 198 feet below the sea level. Okay, so that's problem 59, application of inequalities. So this is when you have two inequalities, so one and the other. Okay, now what if we have, so let's do problem 17. Problem 17, problem 17, 9.217, there it is. Solve and graph. Let me erase this. (17) says minus 10 less than or equal to 3x plus 2 and 3x plus 2 should be less than 17. All right. So x is some quantity that satisfies these two equations. Both. It has to satisfy both at the same time. So for what values of x are both of these inequalities true? Well, first see for what values of x is this true, and for what values of x is this true, and then you will have to combine to see for what values of x are both true. Okay, so you could put this as just minus 10 less than or equal to 3x plus 2, strictly less than 17. You can do that. Or if you want, you can keep them separate. So, okay, let's keep them separate, just to illustrate that, to see that you can do either way. So in the previous example we did when they are both combined and we solve both inequalities at the same time. Now we will do them separately, but you will see that the steps are the same. So for each inequality. So minus 10 less than or equal to 3x plus 2. First thing that you need to do is to either get rid of 2 here or move 3x to the left. So let's move 2 to the left. And so we have minus 10 minus 2 less than or equal to 3x. Okay? So that means negative 12 less than or equal to 3x. Now to find x, I need to divide by 3. Divide by 3, and I get negative 4 less than or equal to 3. Okay? Let me sketch the graph, since it also says in the graph, negative 4 less than or equal to x. Sorry. Okay? Well, you know what? Since I want both inequalities to be satisfied, I need to make sure, let me first actually solve this inequality and then I will graph both, because I want the graphs or the numbers that appear on the graphs to align, and so I need to know what I have as a solution of the second equation. So subtract 2, so 3x is less than 17. Minus 2. So you see here we subtracted 2 and here we are also subtracting 2. So 3x is less than 15. And again, you can skip this step if you want. Alright? Next step is to divide by 3, just like here. Next step was to divide by 3. So 3x is less than 5. You don't change inequality, the sign of inequality, because you are dividing by positive number. Okay? And sorry, that should be x, of course. All right. So x is less than 5. Okay. So there are two distinguished points, two key points: negative 4 and x, and 4. Sorry, negative 4 and 5. So the first equation, negative 4 less than or equal to x. So we need negative 4 number, and make sure for the second graph, make sure that number 5 is right above number 5 on the first graph. So in other words, 5 here should be right from negative 4 here. That's important in order for you easily to find the solution graphically. So the solution, so the second equation is x less than 5. So negative 4 less than or equal to x, or this is equivalent with saying x is greater than or equal to negative 4. So you want negative 4 and above. So that means negative 4 and everything afterwards. So we usually were denoting this by putting a bold part of the x-axis. So minus 4 and above, we use brackets to denote we include negative 4. And here, 5 and less. So it's this. Okay? Less than 5. So not 5 and less. Only less than 5. So we don't include 5. Okay? And now we are looking for x's for which both inequalities are satisfied. So we are looking for x's which are in both of these sets. So we need intersection of them. Okay? To find intersection, just that means to find where they overlap. And obviously they overlap from -4 up to 5. And we do include 4 and don't include 5. We do include, -4. We do include -4 because -4 is included in both of these sets. We don't include 5 because 5, although included here, it's not included in the second requirement for x, so it's not in the intersection. Remember, intersection is a place where both, or the set of points which are in both sets. Okay, so we have this as a solution graphically, but I also want you always to write solution set in the interval notation. So the solution set in the interval notation is interval from -4 to 5, and -4 is included, and 5 is excluded. Okay, so that was number 17. Now, similarly, we do other problems. Okay, let me now erase and do problem 18. Okay, 18. It says, now I will do this faster. I hope the previous problem was clearly explained. So I have now -11 less than 4x minus 3 and 4x minus 3 less than or equal to 13. Okay, so add 3 and you have 3 minus 11, so that's -8 less than 4x, and now divide by 4, and so you will have -2 less than x. This guy, add 3 again, just like you did here, so you will have 4x less than or equal to 13 plus 3, so that's 16, and then divide by 4, just like you did here in the second step, so you get x less than or equal to 4. Okay, so graphically, x greater than -2, so we have -2 here, and x less than or equal to 4, so here is 4, so this is x greater than -2, this is x less than or equal to 4, so this one has solution set graphically represented like this, and this one like this. And so the solution set, since we are looking for x's for which both are satisfied, so the keyword is and, we need to find the intersection, and obviously the intersection is this set. We don't include -2 because it's not in this set, all right? Okay, so the solution set is the interval from -2 to 4, -2 excluded and 4 included. Next problem, problem 19. All right. Let me erase. Number 19. It says 3x plus 7 greater than or equal to 4, and we will do later problems with the or as a keyword. Here so far it's and 2x minus 5 greater than or equal to -1. Now here, these expressions, 3x plus 7 and 2x minus 5, are not the same, so you cannot combine these two inequalities into just one line, as we could in the previous two problems. Okay? So you definitely need to solve these separately. So here you want 7 to move to the right. So 3x plus 7 greater than or equal to 4. So you subtract 7 and you get 3x greater than or equal to 4 minus 7, that's negative 3. Now divide by 3 and you get x greater than or equal to negative 1. Here you add 5 because you have 2x minus 5 greater than or equal to negative 1. You add 5, you get 2x greater than or equal to, and on the right you have minus 1 plus 5, that's 4. Okay? And when you divide by 2, you get that x is greater than or equal to 2. Alright, so the first equation here is negative 2. The second equation here is 2. So make sure that negative 1, make sure that negative 1 is right from 2. Okay, so x greater than or equal to negative 1. So here is the solution. X greater than or equal to 2. Here is the solution. Okay, x greater than or equal to 2. Now we are looking for all values x for which both are satisfied. When you take intersection of these two, the intersection is this set x greater than or equal to 2. So S is interval from 2 to infinity, and 2 is included. Okay? So this is the situation where you have two sets A and B, and A is subset of B. When you take intersection, you will get the intersection is the smaller set, A. Okay? So that's number 19. Now number 20. Number 20. Number 20. 4x minus 7 less than 1 and 7 minus 3x, 7 minus 3x greater than negative 8. Okay, so what about the first one? You add 7 and you get 4x less than 1 plus 7, that's 8. Divide by 4, x is less than 2. This one, you have 7 minus 3x. Subtract 7. Subtract 7. So you have negative 3x greater than negative 8 minus 7, so that's negative 15. Now divide by negative 3, but you will have x, since you are dividing by negative 3, you will have this sign changed, switched. So x less than negative 15 over negative 3, that's 5. Alright? So you have x less than 2. This solution is, so you have 2 and 5. 2 is here. 5 is here. X less than 5. So this requirement gives us this solution set. This requirement gives us this solution set. When you take intersection, the intersection is going to be this solution set. In other words, S is interval from minus infinity to 2, not including 2. And of course not including negative infinity, because we never include infinity. Number 20, next problem. Okay, next problem, number 20. Sorry, we did number 20. Next problem is number 48. 48. So now, two problems with or as a keyword. So 48, 4x minus 4 should be less than negative 8, or 4x minus 4 less than 12. 4x minus 4 less than 12. Now, you cannot, well, okay, all right. So you have 4x minus 4 less than negative 8 or 4x minus 4 less than 12. If you had here 4x minus 4 greater than something, you cannot write in just one line, because writing in just line would mean that you have that your 4x minus 4 satisfies both inequalities. So the keyword is in that case and, all right? But you have or, so you have to separate them. Now, there is one elegant way. If you want some quantity, like 4x minus 4, to be less than negative 8 or to less than 12, well, that means that quantity should be less than 12, all right? But if you're not, so in that case you will get rid of just one, you will just solve one inequality. But if you're not comfortable with that, it's safe just to solve both inequalities and see when at least one of them is satisfied, because that's the keyword or. You have at least one of the equations, inequalities to be satisfied. Okay, so what do we do? Add 4. So you get 4x less than negative 4, and then divide by 4, you get x less than or equal to negative 1. Here you have add 4, and you get 4x less than 16, and so x is less than 4. Okay, so now you have negative 4 is here, and you have 4 is here. So x less than negative 1, sorry, this is negative 1, not negative 4. X less than negative 1 is here, and x less than 4, the solution is this. All right. Now, you are not taking intersection, because you don't want x to satisfy these two inequalities at the same time. You want x to satisfy this or this. That means at least one of them. All right. So in that case, you are taking union. All right. So you are taking union of these two sets. Okay. And so what's the union? Union of two sets. It's a collection of all elements which are in at least one of the two sets. Okay. So the solution actually is this bigger set. Okay? So any x in this set satisfies that property that it is in at least one of the two sets. And any x in this, on this side, does not belong to neither of the two sets here. So this is exactly what we are looking for. The solution set is the interval from minus infinity to 4, and we are not including 4. And in general, when you have one set is a subset of the other one, we said that the intersection is the smaller set. But when you take a union, the union of two sets, one of which is a subset of the other one, then the union is the larger one. Okay? All right, that's number 48. Next problem, number 50, I would say. Okay, number 50. 6 is greater than 2x minus 1. 6 greater than 2x minus 1. Or minus 4 less than or equal to 2x minus 1. 4 less than or equal to 2x minus 1. All right, so let's solve this one. You can add 1, so you get 6 plus 1, so 7 greater than 2x, divide by 2, and you get 7 halves greater than x. Or in other words, x is less than 7 halves, or 3.5. Here, add 1, and you will get negative 4 plus 1, so that's negative 3 greater than or equal to 2x, divide by 2 and you will get negative 3 halves less than or equal to x, or x greater than or equal to negative 3 halves. You can write either one, whichever you are comfortable with. Okay? The first solution graphically is, now the question is which one is larger of the two? Well, of course, 7 halves is larger than negative 3 halves. So for the first equation, we have 7 halves. Here is 7 halves. And 3 halves, negative 3 halves, sorry. Negative 3 halves here. So make sure that negative 3 halves is left from 7 halves. So this is x less than 7 halves. So the solution set is all x is left from 7 halves. And negative 3 halves have x greater than or equal to negative 3 halves. So we include negative 3 halves and everything right from that. Okay? So that's our x greater than or equal to negative 3 halves. And the question is, what is the union? All right? Well, we're not looking for intersection. In other words, we are not looking for where they overlap. We are looking for their union. So we are looking for all x's which are included in at least one of the sets. Well, when you put them together, you will get the entire real line. Any number left from this one is included here. So any number left from negative 3 halves is in the solution, is in the union. Any number in between here is also in the union because it's in both, but it suffices to be in one of them, in both sets. And any number larger than 7 halves is in this set, so is in the union, all right? So actually any real number is in the union. Or in other words, the union of two sets, or our solution set S, is the entire set of real numbers. So all real numbers. All real numbers, okay? Or you can write from minus infinity to infinity. If I ask you for interval notation, so you can write interval from minus infinity to infinity, all right? So much about section 9.2. Now let's see 9.3. Okay, 9.3. We'll first do problem 34. Absolute value of 5x plus 2 equals 3. So for what values of x is this true? Now recall that when you have absolute value of a equals 3, we think of absolute value of a as the distance for the distance of number a from the origin, from 0. So if you want the distance of number a to be 3 units from 0, so it should either be number 3 or number negative 3. These two are the only numbers which are 3 units far from 0. Okay? So in other words, absolute value of a equals 3 means that a should be 3 or a should be negative 3. Okay? So whatever a is. Now our a is a little bit nasty. It says 5x plus 2. So you can think of this as your a. So if you want absolute value of 5x plus 2 to be 3, that means that absolute value, 5x plus 2, or in other words, that a should be 3, or that a, so 5x plus 2, should be negative 3. Okay? Now let's solve this one. Subtract 2, you get 5x less equals 3 minus 2, so 5x should be 1, and now divide by 5, and you get x is 1/5. Okay? Or 5x plus 2 should, or 5x plus 2 can be negative 3. So subtract 2, and you get 5x equals negative 3, negative 2. So 5x is negative 5, and divide by 5, and you get x is negative 1. So you have x equals 1/5, or, the key word is or, x should be negative 1. So the solution set contains only 2 points, -1 and 1/5. And remember, we said this is totally different from, let's say, -1, 1/5, where this means set of all numbers in between -1 and 1/5. And that set is infinite. There are a lot of numbers in between -1 and 1/5, but this set here just has 2 elements, namely -1 and 1/5. Okay, so that was problem 34. That was the solution set. Okay, you cannot write this in interval notation. You can also write this in this so-called set builder notation when you have these curly braces. Okay, that's problem 34. Let's see problem 35. 35, absolute value of 4x minus 9, just a second, 4x minus 9 equals 14. Okay? Alright, again, absolute value of a equals 14 means that a should be either 14 or minus 14. So either this thing under absolute value should be 14, or that thing 4x minus 9 should be -14. So here add 9 and you get 4x equals 14 plus 9, that's 23, and now divide by 4 and you get x equals 23/4. Okay? Here add 9 and you get 4x equals 9 minus 14. Now this is minus 5, and now divide by 4 and you get x equals -5/4. Okay, so x should be this or this. All right, so in other words, the solution set is I usually write the smaller one first, but you can write whichever you want. You can write first. Okay, -5/4 and 23/4. So this is the solution set. Okay, so that's 35. Now let's see problem 48. Problem 48 says absolute value of 4 minus 5x divided by 6 equals 7. Okay, we said when you have absolute value of a over b, that's absolute value of a divided by absolute value of b. So this is absolute value of 4 minus 5x divided by absolute value of 6. But absolute value of 6 is just 6, so I can write 6 equals 7. Let's first get rid of fraction by multiplying by 6. So I have absolute value of 4 minus 5x equals 42. So I just multiplied by 6. And now it's like you have absolute value of a, so this is like your a, equals 42. So a should be 42 units far from the origin. So that means a should be 42 or minus 42. In other words, 4 minus 5x should be 42, or 4 minus 5x should be -42. To solve this, you have to subtract 4, so you get 38 after subtracting 4, 38 on the right, and you have x is -38/5 after dividing by 5. Here you have -5x equals -42 minus 4, so that's -46. So x is -46 over -5, so that's just 46 over 5. So the solution set, since this is or, here, or the solution set contains 2 points, negative 38 fifths and 46 fifths. Okay. All right. Next. Next, number 54. Number 54. Number 54 says absolute value of x minus 6 equals negative 8. Now, you can think again, whenever you have just absolute value of a, you can think of this as the distance of a from the origin. And the distance is always greater than or equal to 0. We know that absolute value of any number a is greater than or equal to 0. So if you want absolute value of x minus 6 to be negative 8, that will never happen. Whatever you have here under absolute value of that quantity is always going to be greater than or equal to 0, so it will never be negative 8. So no solution. In other words, the solution set is the empty set. Remember, this is how we denote empty set. So S is empty set. Okay? And if you had absolute value of x minus 6 less than 0, so let me do another example. It's not a problem from the book. So suppose you have this absolute value of x minus 6 is equal to 0. So the distance of x minus 6 from the origin should be 0. So that means that number should be the origin itself. So x minus 6 should be 0. And so that means x is 6. All right? Next problem. Next problem, I would like to do 58. 58. Number 58. Absolute value of 2x minus 8 is equal to absolute value of x plus 3. Okay, so for what values of x is this true? Well, this is the distance of 2x minus 8 from the origin. So, or actually, just to remind you, if you have absolute value of a is equal to absolute value of b. So you can think of this as a distance of a from the origin, and this is distance of b from the origin. So if this is the origin, 0, and a and b are numbers, so that their distances from the origin are the same, okay? So if this is, let's say, absolute value of a, and if that should be the same thing as absolute value of b, then a and b should either be both here or both here. So in those two cases, that means a is equal to b, or one of them is here and the other one is here. Say a is here and b is here, or a is here and b is here. But in either of the two, of the last two cases, so if they are on opposite sides of 0, one of them is minus the other one, right? A is minus b, or equivalently b is minus a. So, so this is just recapitulation of what we had last time. So we said actually that absolute value of a is equal to absolute value of b if a is equal to b. So that's the situation when either both are here or both are here, or when they are on opposite sides, a here, b here, or b here, a here. So that's when a is minus b. Okay, in both situations you can write, in both of these two last situations you can say A is minus B. Okay, so you can think of this as your A and this as your B. So this will be equal to each other if the quantity under the first absolute value is equal to the quantity under the second absolute value. So if 2x minus 8 is x plus 3, or if the quantity under first absolute value is minus the quantity of the second, under the second absolute value, all right? No other way you can solve this. So you can get rid of, you can have absolute value of x plus 3 is x plus 3 or minus x plus 3 or something like that. No, 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 no. You have to write in this way, okay? Now, to solve this, move x to the left and you will have x minus 8 equals 3 because 2x minus x is just x, all right? And now move minus 8 to the right and you get x is 11. Or, to solve this, you first distribute minus sign, so you have 2x minus 8 equals negative x minus 3. Now move minus x to the left, in other words, add x, so you will have 3x minus 8 equals minus 3. So add 3 and add 8, and you will have 3x equals 8 minus 3. That's 5. And finally, divide by 3. X is 5/3. So x should be 11 or 5/3. So the solution set. So again, the keyword is or. S is 5/3 or 11. So this is the solution set. Okay, that's problem 58. 58. Now let's do which other problem? 60. Problem 60. Problem 60. From 9.3 says absolute value of x minus 15 equals absolute value of x plus 8. Now again, this is equivalent with this or this. So to get rid of absolute value symbols, you will have to have that x minus 15 is equal to x plus 8, or x minus 15 is the opposite of x plus 8. A common mistake is the students who don't prepare well for the exam, they make a common mistake just by writing this is equal to this. In other words, if absolute value of A is equal to absolute value of B, then A is equal to B. But that's wrong. Just take A to be 5 and B to be negative 5. It is true that 5 is negative 5, but it is not true that A is equal to B. In other words, it is not true that 5 is equal to minus 5. Okay? Okay. So if you don't include this possibility, you will lose one possible solution, and actually you will lose more than half of the points on that problem, okay? Because you really didn't solve the problem. Okay, so here you have x minus 15 equals x plus 8. Well, let's subtract x, let's move x to the left. But then you will have x minus 15 equals 8, okay? In other words, minus 15 is 8. Well, for what x is this true? Well, for no x, okay? So this doesn't give us anything. So this requirement doesn't lead to any x. No such x exists for which x minus 15 is the same thing as x plus 8. Okay? Now, what about this one? Get rid of minus. Okay, so we'll have x minus 5 equals, distribute minus, so minus x minus 8. X minus 5 equals minus x minus 8. Now add x to both sides and you will have 2x minus 5 equals minus 8. Now add 5 and you get 2x equals minus 8 plus 5, which is minus 3. And so divide by 2 and you get x is negative 3 halves. Okay? So the only solution, or the only x that satisfies this is x equals negative 3 halves. So the solution set is negative 3 halves, and that's it. 1 point set. Okay? That was problem 60. Okay? Now, what else? Now, problem 80. Problem 80. Okay. Problem 80 says 5x plus 2, absolute value of 5x plus 2 should be less than or equal to 3. Okay. All right. So let us recall, what does that mean, absolute value of a less than or equal to 3? Again, think of absolute value of a as distance of a from the origin. Okay, so the distance of a from the origin should be less than or equal to 3. So what are candidates for a? What are all possible values a for which this is true? So here is 0 and here is 3. You are looking for all numbers a which are a distance less than or equal to 3 from the origin. Well, this number definitely satisfies that. So does this one, so does this one, and 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 this one. And even 3 satisfies that its distance is less than or equal to 3 from the origin, okay? But now if you take this number here, larger than 3, its distance is larger than 3. So you include just these points here. But this point here is also at the distance less than 3, and so is this one, and so is this one. Well, up to what point? Well, if this is 3, just flip it over. This is minus 3. And actually, you see that any point in between negative 3 and 0 also is at distance less than or equal to 3 from the origin. So actually, all the points in between negative 3 and 3, and including negative 3 and 3, because we have or equal to 3. Okay, so absolute value of a less than or equal to 3 means that a is in between negative 3 and 3. If we had strict inequality, then we would have had negative 3 strictly less than a, strictly less than negative 3. Strictly less than 3. Okay. So in this case, our a is 5x plus 2. So you have 5x plus 2 should be greater than or equal to negative 3 or less than or equal to 3. Okay. Now you have two inequalities to solve. This one and, the keyword and, this one. Okay. So you can solve them at the same time. Subtract 2 from all sides and you will have minus 2 minus 3 less than or equal to 5x less than or equal to 3 minus 2. I just subtracted 2 from all sides. So 5x plus 2 minus 2 just became 5x. That's why I have this. This is minus 5 less than or equal to 5x less than or equal to 1. Now to get rid of this coefficient 5, divide by 5 and you get -1 less than or equal to x less than or equal to 1/5. Okay? If you were supposed to divide by negative number, these inequalities will switch to these inequalities. Okay? If you are dividing or multiplying by a negative number. That was not the case here. So this is the solution. X should be greater than or equal to -1 and x should be less than or equal to 1/5. In other words, the solution set is the closed interval from -1 to 1/5. The closed in the sense that you include the end points. Okay, that is number 80. Okay, now let's do number 87. Number 87, absolute value of 2x plus 3 less than or equal, well actually it says less than or equal to, but let me do one problem. Well, okay, let me do 87 modified in the actual problem 87 in the textbook. It says less than or equal to 4, but I will do strictly less than 4. Okay, so again, absolute value of a strictly less than 4. The distance of a from the origin should be strictly less than 4. What are those numbers? Well, anything up to 4, between 0 and 4, but also anything in between -4 and 0. So actually all the numbers in between -4 and 4. So a is strictly greater than -4 and strictly less than 4. It's strict inequality because we have here strict inequality. So 2x plus 3 should strictly be greater than -4, but strictly less than 4. Now subtract 3 and you will have a -7 less than 2x less than, and when you subtract 3 from here, you get 1. Now divide by 2, so you will have -7/2 less than x less than 1/2. So the solution set, because this is and, both inequalities have to be satisfied, S is the interval from -7/2 up to 1/2. Open interval. I mean, we don't include neither of the endpoints. Okay? Now let me do problem 82. Problem 82 says absolute value of 2y minus 7 is strictly greater than 10. When you have strictly less than, so the distances of this guy is less than some positive number, so those are numbers around 0, okay? But now if you have, let's say, if you have absolute value of a is less than or equal to 10, so we eventually want to solve something of the kind absolute value of a is strictly greater than 10. Well, let's see what if opposite of that is true. So if absolute value of a is less than or equal to 10. If absolute value of a is less than or equal to 10, that means, so here is 0, so the distance of a from the origin is less than or equal to 10. Here is 10, here is minus 10, and all numbers in between, so from minus 10 to 10, are such so that their distance from the origin is less than or equal to 10, okay? So, but you are now looking for the opposite. So the opposite are all numbers of strictly less than -10 and strictly greater than 10. All right? So we are looking for all values 2y minus 7 such that 2y minus 7 is less than negative 10. Okay? Or, so it is also allowed y to be, it is also allowed 2y minus 7 to be here. So that means or, that's the key word, or 2y minus 7 greater than 10. Okay? And now let's solve both equations. So add 7 and you get 2y less than negative 10 plus 7, that's negative 3. Divide by 2 and you get y less than negative 3 halves. Or this should be true. So add 7 and you get 2y greater than 10 plus 7 is 17. And now divide by 2, so you get y is greater than 17 halves. Okay? So the key word is or. Now let's find the y for which this or this is true. Okay? So this is y less than negative 3 halves. And this is graphical way of representing y strictly greater than 17 halves. Okay? Negative 3 halves is smaller than 17 halves, so I will write negative 3 halves left from 17 halves. So this equation says, inequality says y is strictly less than negative 3 halves. So this part, left from negative 3 halves. And this guy says right from 17 halves. Okay? So y should be here or here. Because we have or, that means we take union of these sets, and the union is going to be everything here or here. All right? So this is negative 3 halves, and this is 17 halves. All right? So the solution set S is, now since they are separated, the only way to write their union is using that symbol U for union of the two sets. So you have interval from minus infinity to negative 3 halves, and we don't include, so nothing here is included. Endpoints are not included. So not included negative 3 halves. Union from 17 halves to infinity. So that's the solution set. And that's all what I had for you this time. All right, good luck guys preparing the exam. Take care. Bye.